moles of ozone change into 3 moles of oxygen gas. Temperature is 300 Kelvin and ozone is 50% dissociated. The standard free energy change at this temperature and 1 atmosphere pressure is minus dash joule per mole, and given natural log of 1.35 is 0.3, value of R is given. Answer has to be given in nearest integer. 2 moles of ozone change into 3 moles of oxygen. So 2 moles of ozone, 3 moles of oxygen. 1 mole of ozone will give 3 by 2 moles of oxygen. So if alpha moles of ozone is there, then 3 by 2 alpha moles of oxygen will be formed. Now alpha is the degree of dissociation. How to find the degree of dissociation? It is given in the question that ozone is 50% dissociated. 50% means out of 100, 50 moles is dissociated. If initially 100 moles is present, then 50 moles is dissociated. Therefore, out of 1, how many moles will be dissociated? Out of 100, if it is 50, then out of 1 it will be 50 by 100, which is equal to 0.5 moles. And this is the degree of dissociation denoted by alpha. So out of 1 mole, alpha moles is dissociated, and when alpha moles of ozone dissociates, it gives 3 by 2 alpha moles of oxygen. So remaining ozone at equilibrium is 1 minus alpha, and oxygen formed at equilibrium is 3 by 2 alpha. Putting the value of alpha and solving, moles of ozone is 0.5 and moles of oxygen is 0.75. So total moles will be 0.5 plus 0.75, which is 1.25 moles. Now partial pressure of oxygen is equal to moles of oxygen divided by total moles multiplied by total pressure. So this is equal to 0.6 atmosphere. Partial pressure of ozone is equal to moles of ozone divided by total number of moles multiplied by total pressure, and partial pressure of ozone is 0.4 atmosphere. Value of Kp will be partial pressure of oxygen raised to the power 3, because 3 is the stoichiometric coefficient of oxygen in the balanced equation, divided by partial pressure of ozone raised to the power 2, as 2 is the stoichiometric coefficient of ozone in the balanced equation. Putting the values of partial pressure of oxygen and partial pressure of ozone and solving, value of Kp is 1.35 atmosphere. Now delta G is equal to minus RT natural log of K. Putting the value of R and T, natural log of 1.35. This is natural log of Kp. So natural log of Kp means natural log of 1.35, which is given in the question as 0.3. So value of delta G is minus 8.3 into 300 into 0.3, which is equal to minus 747 joule per mole. So here the answer will be 747. Minus sign is already given in the question, so 747 joule per mole.